Um, okay, so everybody, welcome to the second installation of the AIAA Space Resources Technical Committee Education and Outreach Space Resources webinar series. I'm Jared Longfox. I'm the vice chair of the Education and Outreach Subcommittee, and with me here I have Joe Kenrick, the chair. I'm from the University of Central Florida, Center for Lunar and Asteroid Surface Science. Joe, you want to introduce yourself?
Yeah. Hey, everyone. So my name's Joe. I'm working with Lunar Outpost, actually in the process of moving to Australia in the next couple hours to run a program for the Australian Space Agency out of Melbourne.
And so everybody, wish Joe good luck on a move to the antipode of the Earth.
The blood will be rushing to your head tomorrow, Joe.
Nice.
So the purpose of this webinar series is to involve anybody interested in space exploration, space resources, general public, students, undergraduate or graduate, lifelong learners, professionals in industry, academia, government. We are just trying to get the word out about how space resources can be used, how we, as a global community, will be leveraging these resources, responsible ways to use them, plans, priorities, etc. And on that note, I have a couple of quick announcements to make. Our Space Resources Technical Committee is seeking support to build an authoritative and regularly updated publicly available space resources technology performance and cost database. This effort is being led by George Lordos, and we hope that the final product will become a go-to database for mission architects and lunar development community who wish to infuse ISRU technology into their mission concepts and business plans. I'll be in just a moment, I'll be pasting in a link to a survey that I would love if you guys could fill out. It'll give us plenty of good data. So keep an eye on the chat for that, and I'll repost it at the end of the webinar. But for first things first, I'd like to introduce everybody to, assuming you don't know him already, the illustrious Dr. Clive Neal of Notre Dame University. Clive has done it all in lunar science, from sample science to pushing policy forward on governmental levels. So Clive, if you have anything else you'd like to add, otherwise.
Well, I'm an old white guy. How about that? It's been around for a few decades now, and get very passionate about what I'm about to talk about today. So I hope you'll have lots of questions.
And absolutely. And we will be having a Q&A session once Clive's done with his talk. So for those of you not familiar with it, there is a Q&A button on the bottom left-ish side of your screen. So go ahead and feel free to punch questions in there as you have them, and we'll get to them afterwards. So without further ado, Clive, I'll leave this to you.
All right. Thank you, Jared. Thank you, Joe. And all right, I'm assuming everybody can see that now.
All good.
All right. So talking about in situ resource utilization, and I've been listening to a lot of talks from the Lunar Surface Innovation Consortium about ISRU. I've been a couple of times now to the Luxembourg Space Resources Week, and all this good technology about in situ resource utilization capabilities. And it's very important to have that ready, but there's an immediate next step that needs to be undertaken now in order to understand if going to the moon with humans, we can actually use the resources there to sustain human exploration and drive the cislunar economy. So what I'm going to do is to go through, and I'm going to point to some leading documents about where resources and economy come together. Because if you read these and you listen to the presentations that are out there, that resources are going to be underpinning a vibrant cislunar economy. And I hope that's the case. I really do hope that's the case. But what do we need to do? Well, we need to understand what are potential lunar resources. I've been thinking quite a bit about this, and I can sort of give you four major categories. The one that everybody is talking about in the polar volatile deposits. This is why the Artemis program is going to the South Pole. This is why the United States and Russia and China are building outposts at the South Pole to be close to the reportedly billions of tons of water ice that are present at the South Pole of the Moon. Well, there's other resources as well, and if you go anywhere on the Moon, you have regolith. And regolith, if you see in the top right diagram there, if you look at regolith from the low titanium Mare basalt, high titanium Mare basalt, and highlands areas, contains pretty much the same amount of oxygen. So maybe this is a resource that's anywhere on the Moon. And in addition, you can also get various metals that can be used for construction. They can be used to enable human permanence on the Moon. And within the regolith, we've got solar wind implanted volatiles. We can use the bulk regolith as for bulk 3D printing of habitats. Maybe I've seen a lot of companies doing it down here. Icon, for example. We see solar wind implanted volatiles, as I said, the platinum group metals that have been deposited there through billions of years of meteoroid and asteroid bombardment. If you go to the prosolarum creep terrain, are there potential rare earth element resources that may be a potential export back to Earth? And what about the radioactive elements, thorium and uranium, that could be used for fueling fission reactors, off-world fission reactors? I mean, it's near term in terms of the polar volatile deposits or using volatiles on the Moon. It's a long term if you go down that list with regolith. But there's also pyroclastic deposits which are away from the poles, which also contain volatiles. Maybe not as much as what's in the in the permanently shadowed craters. We still need to figure that out, in my opinion. And if you look at the pyroclastic deposits, they're much easier to deal with through electrolysis, because you don't have to break down a crystal structure, so less energy is going to be involved, and you can get volatiles and metals out of those as well. And there's another in situ resource that's very important to consider now, and these are lava tubes and impact craters. Lava tubes for putting habitats below ground. It negates those thermal swings from lunar night, lunar day, and it also affords protection from meteoroid bombardment and radiation. Those are critical things to consider if we're going to put a habitat on the Moon. And if you look at the sort of the representations of the Artemis habitat, a tin can on the surface is not going to afford any protection to the astronauts from radiation or meteoroid bombardment. It would need to be buried at least 2 meters or covered in 2 meters of regolith to at least protect it from micrometeoroid bombardment, and also from radiation, not only the primary radiation that comes in from both the sun and the galaxy, but also from secondary radiation that is generated by these high energy impacts into the regolith. And then we have impact craters, which are another resource. These could be used as smaller ones to actually have an in situ solar array, or an in situ dish, to put a dish in an impact crater, just as a dish was put in a sinkhole in Puerto Rico. These are things to be considered in the near term and the long term as we go through. So this is how I'm thinking about lunar resources, the ones that could be used in situ, and there's also potential for export, depending upon the economic value of those resources. And I want you to remember that, because the motivation here is that in the ISRU value chain, we have two log jams. We talk about resources, and many of the documents that I've read, resources are used when they actually mean reserves. And that means, I'll get to that definition in a minute, but we need to know if there are reserves, and we simply don't have the data and the fidelity in the data necessary to determine a reserve. But maybe more fundamentally, there's no economic driver, there's no pull for understanding if we have reserves from the demand or markets and customers. So we've got two log jams, and we really need to understand how to overcome those log jams. So spoiler alert, I'm going to tell you the whole point of this presentation is that the immediate next step is to develop a lunar resource prospecting campaign that would give us the data to understand how much we have of these resources, how extractable they are, which would require understanding the geotechnical properties of regolith and the materials within the regolith, and whether or not we can actually refine and use those products in situ. So I want to start with our space policy. We are living in a unique time because the United States has actually now had a space policy that has transcended an administration change. We still have the same policy that was devised through the National Space Council and the Trump administration, and it continues on today. And this is unprecedented. But it's good news because it allows NASA to focus on a destination, or destinations as it is, Moon and Mars, to make progress in getting humans outside of low Earth orbit. And I highlight this bit from the space policy. Extend human economic activity into deep space by establishing a permanent human presence on the Moon. Not a sustained presence, not a fleeting presence, but a permanent presence. And NASA is not willing to actually use the P word in their documents, so we have sustained presence. But the goal of a permanent human presence is going to be important for driving the importance of resources, because there's now going to be a demand in order to support the humans that are on the Moon and allow a growing population on the Moon. There's also the long-term commitment to that in terms of the term permanent there. So bringing along industry and international partners to develop infrastructure and services that will enable science-driven exploration, space resource utilization, and eventually human missions to Mars. So this is, I think, underpinning the whole point of why we need to look at lunar resources as a critical next step, immediate next step, in order to fulfill the long-term goal of permanent human presence on the Moon. And this is, again, further exemplified throughout this document. And you can see here, why are we going out to put humans beyond Earth? Well, it's to increase the quality of life for all humanity. I always say in my classes I teach here, the reason we send humans into space is to make life better down here. And if we're not making life better down here, why are we doing it? We have to have that spin back potential that comes from all the technologies that have been developed to get humans off planet. I mean, I often hold up my cell phone and say, okay, thank you, Apollo. Miniaturization of electronics. Now, the cell phone wasn't designed by Apollo, but the capability to have that design is something that that I think was unimagined at the time, but it has proven to be a fantastic economic driver, and this is something that will enhance space exploration in terms of it is creating jobs, it is creating wealth, and it is creating science and exploration opportunities that have been unimagined. So let's look at some of the documents that have come out. Here's an Artemis rollout overview from 2020. In the overview, it says US will establish a predictable and safe process for the extraction and use of space resources following the Outer Space Treaty. Again, in this section, Artemis after 2024, we will develop new technologies that advance our national industries and discover new resources that will help grow our economy. And then in robotic missions, again, we need to have these robotic lunar surface scouts they're essential to validating the observations and preparing for human habitation and utilization of the moon's rich array of resources from volatiles to minerals, hinting at a prospecting campaign, I believe. We then look at the full rollout, the follow-on document, which is much bigger. Again, lunar resources, there's a whole section on lunar resources. And as our sustained presence grows at the moon, opportunities to harvest lunar resources could lead to safer, more efficient operations with less dependence on supplies from Earth. And in the Artemis Accords that are appended to this document, it talks about the abilities to extract and utilize resources on the moon, Mars, and asteroids that are critical to support safe and sustainable space exploration and development. Now, one of the things that immediately popped out to me was, what does sustainable mean? It's used a lot: sustain, sustainability, and sustainable. And it's important that we understand how people are interpreting these terms. Before the reorganization, the Human Exploration and Operations Mission Directorate had this document that came out, and lunar polar volatiles of high priority for both science and exploration. And again, STMD in their objective in this document, commercial scale ISRU production utilization capabilities including sustainable commodities on the lunar and Martian surfaces. But we really need to know if we have reserves on the moon and Mars. So there's talk from NASA headquarters about Artemis being a blueprint for Mars and how we will do human space exploration out into the solar system. Well, one of the things that we need to do is to bring industry along with us. In order to do that, there has to be an economic aspect to it. So we need to understand if we have reserves. We fast forward now to last year when the revised Moon to Mars objectives came out. If you look at Applied Science Objective 3, characterize accessible lunar and Martian resources, gather scientific research data, and analyze potential reserves to satisfy science and technology objectives and enable ISRU on successive missions. Lunar Infrastructure Objective 7, demonstrate industrial scale ISRU capabilities in support of continuous human lunar presence and a robust lunar economy. Well, resources aren't going to cut it. It's going to have to be reserves. And then Operations Objective 3, characterize accessible resources, gather scientific research data, and analyze potential reserves to satisfy science and technology objectives and enable use of resources on successive missions. So it's good to see both terms, resource and reserve, being used, but we need to understand the difference. I don't know how many geologists are out there, but this is an important distinction that gets lost sometimes. So if we look at a resource then, and this comes from the USGS publication from 1980, a concentration of naturally occurring solid, liquid, or gaseous materials in or on the crust in such form that economic extraction of a commodity is regarded as feasible. Now, a reserve is that portion of an identified resource from which a usable mineral or energy commodity can be economically and legally extracted at the time of terminations. So the little illustrative diagram there shows you that if we understand where the resource is actually being found, we can then make assumptions that when we find geologically similar areas, they should be there. They're the undiscovered districts to the right in that diagram. We found them in known districts. We have those known, for example, with the PSRs in the at the north and south pole of the moon. But what we don't know is the yellow box there. How big is that yellow box in terms of the different lunar resources that I highlighted at the beginning of the talk? We don't know that at all, and we need to understand a campaign, or we need to set up a campaign to actually define that reserves box. That is what is going to make ISIU feasible, because it's going to be important for bringing along the private sector, getting those involved, getting those folks involved, and then you get momentum because we're now creating jobs in the private sector through NASA's budget, and we're not just making it a drag on the taxpayer. And they say, I applaud NASA. They've now done their second, the economic impact of NASA's budget, which shows just how much revenue the $20+ billion a year that NASA gets actually puts into the United States economy. And that is now increasing because of the CLIPS program. If you look at jobs in the CLIPS program, in those CLIPS companies, I did some statistics after getting their hiring data. It was shown that in 2019 it was over 100% job growth in those companies. But then we had the pandemic and everybody was being laid off. Well, in those companies, they only hired they only grew by about 66% in 2020. Still waiting to get the time to do the 21, 22, 23 growth statistics to see how that's continued. But it shows that this is there's commercial interest in this, and we can grow that by understanding if the resources on the moon are going to be reserved. So I come back to this. How are we going to do this? How are we going to show that we have reserves of lunar resources? But I also want to point out that this idea of what does sustainable mean? And this was a 2020 document from the National Space Council, and I found it to be quite masterful in terms of defining what sustainable means. And you can see here, they actually state on page 3, sustainable can have different meanings depending upon the context. So they've defined it, they've given it a 3-pillared definition. Financial sustainability. If you think about this, this is NASA's budget. We are able to do what is laid out in the United States space policy within our projected budgets. How much money is going to be there? And this technical sustainability. What technologies do we have to actually de-risk it? What is the acceptable level of risk that will be sustained and will allow a long-term commitment from the country to go forward? And then there's the policy sustainability. And the program's financial and technical factors are supportive of long-term national interests. And this is why the idea of Moon and Mars as destinations in our space policy has done something that has never happened before. And again, as I said, this transcended an administration change. So during 2020, I think everybody had quite a bit of time to think, and suddenly came to me that what we need is a lunar resource evaluation campaign. And the reason I use the term evaluation is prospecting turned off the Science Mission Directorate. because that's not science. Well, we'll argue about that. But this was this is you see here the core group that got together to actually follow up on this in terms of an international lunar resource evaluation campaign. So what have we done? Well, we put the first idea out there at the LSIC 4 meeting in 2021. Again in 22, there was a talk at the Luxembourg Space Resources Week. And there was one also this year, last month. And then also at the 2022 IAC in Paris. We had 2 lunar surface science workshops, 17 and 18. And I'm going to present to you some of the findings from those workshops. And we've also got a peer-reviewed paper under revision in Acta Astronautica right now. Well, we've got the reviews back and it's just waiting for us to get on it and get it reviewed. But it looks like it's accepted, subject to revision. So the LSSW 17, it highlighted the need for understanding if lunar resources are reserves and the types of data that are needed to do that. And again, if you look at the list there that's in the table, there are still questions. What is the required fidelity, so on and so forth. But we actually know the types of data we need, but you're not going to get many of these data sets from orbit. You're going to have to go to the surface. But we need the orbital data in order to understand where to send these non-trivial and somewhat expensive surface assets. Or we could think about ways to do it more cheaply to get the specific data sets. If we look at the 10 most promising sites for polar volatiles, they cover an area of over 6,000 square kilometers. So that's just polar volatiles. So this has to be a campaign, but it cannot be one country leading it because it's going to bust the budget. So it needs to be an international in scope, and it needs to be coordinated such that we can integrate different data sets. So if we look at the other findings, coordinating data gathering efforts, as I just said, we could do that from current and funded missions that are capable of providing information on the resources. We can define the explicit measurements and fidelity needed so we can derive those useful products for future missions and where to send them. Developing lunar resource and reserve standards and evaluation metrics. This is something that is done on this planet, and there's been a move in Europe to actually do that. Carlos Espejel is the man that has developed lunar or reserve standards metrics, and that should be coming out or in I think next year in the peer-reviewed literature. Inclusion of partners in this effort, including non-spacefaring nations, and this is why I really like the Artemis Accords, because if you look at who signed the Artemis Accords, up to 24 now, with I believe 2 more getting ready to sign, there are non-spacefaring nations that have signed up for that. And then defining a data policy or data policies and exploration rights. How is that going to be done? And then leveraging private industry and developing a list of high priority targets from existing data sets, and then developing mission concepts that may be conducted from orbit that would allow better positioning and could be near-term, easy win, if you like, missions that could be implemented through a CLIPS delivery to lunar orbit. If we look at the 18, LSSW 18 findings, defining lunar reserves. So we really need to combine orbital and surface ground truth data. Data products are going to be highly processed, so these standards are going to be critical. For example, the quantitative assessment of uncertainty is really important when you're pinning a business model on the data that you're getting. And resource discoveries can only be claimed once ground truth surface data have been obtained, because we know that there's water ice in these permanently shadowed craters, but it's unobtainium until we know if we can access them, if we can get it out, if we can refine it in situ. And then if you look at a coordinated international lunar resource evaluation campaign, it will be compliant with the Outer Space Treaty. It will enable cooperation at various levels of involvement. It increases efficiency and reduces costs to any one nation. But one of the things that came out of it, this should be coordinated by a neutral broker, a non-governmental agency is the way to think about it. Next steps, identify founding partners, convene an initial preparatory meeting for the campaign, identify the neutral entity that's going to be the coordinator, and then develop reserve standards, information requirements, and produce much needed data. Now, LAWS is the Lunar Oil Reserve Standards has actually gone a long way to developing those standards, as I said, and hopefully you'll be able to access this link because it gives it a bit more detail. But again, from my mind, we really need to get this out in the peer-reviewed literature. So, beginning the coordination. On the left there, you see a ongoing and scheduled missions that are coming up, and there's a mixture there of orbital and surface. Okay. There's also the China and Russia ones. How do we coordinate with them at the scientist to scientist level? I don't see any issue with that. However, politics will get involved, and it may limit those scientist to scientist interaction. And again, the question remains, who does the coordination? So if we think about it, we look at those missions that we can easily talk to and collaborate with. We have polar volatiles focus in these. We could have international community workshops to define the PSR targets if we're going to start with the polar volatiles. There could be other targets that could come up as well. But the important thing here is, why can't that non-governmental entity that does the coordination, why can't that be a community-driven consortium to do this? Why does it have to be some mythical entity or maybe a space agency to do it? Why can't we do the coordination, at least the initial coordination? So we could work with mission PIs. The mission PIs are part of our community, but we work with them to get multiple data sets for the same target, not the same data set, but for different instruments. We can integrate that with current data sets. And as a community, we can define targets for surface asset investigations. And the data that we get would not only inform exploration, but it would also inform science and commercial interest and commercial involvement. So this is something that when I presented at Luxembourg, we actually had an in-person meeting of the core group, which actually grew to 15. Anybody is welcome to contact me to be part of this, and we are now in the throes of contacting these different missions and asking them to be part of this coordination. This is not mandatory, it's all voluntary. Some missions have a targeting, what's the web interface, so you can actually ask them to target specific areas. So we can do it that way as well. So again, why can't we do the coordination? It would be a lot quicker and a lot simpler if this was a community-driven coordination rather than either a non-governmental agency or a governmental agency. So I think that this is something that we're going to push, and I think then we would be able to get some results with these ongoing and scheduled missions. So how would we then expand the coordination? As I said, refine through peer review the laws concept. We could include partners, Artemis Accords, ISEC-G is another one, International Space Exploration Coordination Group. We could have target identification based upon existing data. We could leverage commercial industry. And one idea is to actually develop on the existing data a potential reserve report that would then help the existing coordination or the coordination of existing missions, and then help us then define places on the surface where new missions should go. There was an interesting workshop at NASA Ames between NASA and the USGS about technologies to fill observation and capability gaps for the off-world mineral resource economy, and that should be recorded and it should be available at that link there. Very interesting workshop. So, coming back to the Moon to Mars objectives, it's interesting that reserves are called out in these objectives, and also linked to a robust lunar economy. But we have to show that we have reserves on the moon. And as I said right at the beginning, it requires two things. We have that pull from the market or the demand, and we have the push from the data that we need in order to show the reserve potential of lunar resources. So, summary. In the white there, the term resources has often been used when reserves is the correct term for the context. To identify reserves on the moon, a campaign of landed and some orbital missions will need to be coordinated. The coordination can be started with existing and scheduled missions that have the potential to yield data on lunar resources. And I think we can do that coordination. A coordinated International Lunar Resource Evaluation campaign is the most critical next step for the moon. It holds so much importance for the aspirational goals of the Artemis program and also of our space policy. To show that we have reserves on the moon, or at least high reserve potential of these resources, would be important for creating human permanence and also developing this vibrant cislunar economy. And I really think the initial coordination, at least, can be done by an open international community group rather than waiting for other entities, because it doesn't seem as if those other entities are either there or willing to do this. So my last slide, the future. The moon is our enabling asset. It's the near world off proving ground, and you can see that in the Moon to Mars objectives. And again, this is something that we can perfect at the moon, take to Mars, adjust accordingly for the different environments, and then who knows where else humans can go. That's outside my lifespan, but maybe not for some of you listening here. So resources could be enabling for a rapid development of this cislunar economy, but we need to verify that reserves exist. And by doing this, we develop this blueprint from the cislunar economy that could potentially build a cis-Martian economy. And I think that is something that we need to take a multi-decadal look at in terms of where we are now and where we want to be 40, 50 years from now. This is the way that space exploration should always be done, but we need to stay the course. But we have a space policy that is actually very encouraging for having our space agency stay the course, and along with our space agency, others around the world in terms of those that have signed the Artemis Accords. And I'll leave it there. Thank you very much.
Excellent. Thank you very much, Clive. A wonderfully informative and thoughtful presentation on a highly relevant topic. So I guess we'll move on to the Q&A. I see we have one in right now from Hunter Williams, who asks, technical sustainability can be a stacking. For example, grad students would have a much harder time building new tech if our grid had power surges every day. So the question is, what element of technical sustainability do you see as the most consequential to the ecosystem of lunar permanence?
That's a very interesting and convoluted question there. It doesn't look convoluted, but it really is. It comes down, I think, to standards. You talk about we need power. Well, how much power? Well, Elsick is talking about this. Okay, well, what's the cleanliness of that power? And this is something, if you think of it, when I came to Notre Dame, I had to set up a clean lab. Well, immediately I had to describe what clean meant. I had to quantify, what do you mean by a clean lab? Because I'm a geologist, and so I had to learn what requirements meant. So that's the thing. What do we mean by clean power? All right. What do we mean by, well, we need life support consumables? What is we know that we need pretty clean stuff, but we know from Apollo 1, we don't want pure oxygen. And this is something that that we need to think through. So if you look at the operations portion of the Moon to Mars objectives, there are a number of things that are very high level, but the Space Technology Mission Directorate is starting to drive down to that. So I really think standards are important. We need to define those, and then we need to implement those at the base camp. And the base camp I'm talking about in generic terms, in terms of Moon and Mars. We need a base camp. Listening to Jim Free speak today on the most recent LSSW, a distributed base camp is something that I really think is important to consider, because if you have one base camp and it gets taken out by a meteoroid strike, you have nowhere to go for long term. So that's a level of technical risk that needs to be reduced, I think. So good question, Hunter, and we could spend an hour talking about it. Maybe we should, but not today.
Well, yes. So, all right. I see in the Q&A, I think the only place you can chat, Donald Barker put a suggested reading on lunar resources and associated problems. I'll put that in the chat in just a sec. But the next actual question is...
oh, that's Don's paper. That's Don's paper. It's all right. I know all about Don's papers. So, and I appreciate that, Don. You're doing yeoman's work, man.
Perfect. So Chris Zachney asks, what, in your opinion, are options for collaboration with China on the moon?
Chris, I would say scientist to scientist, very good. If we look at the way the Chang'e 3 samples were analyzed, I was on an international consortium that got some of the first ages out of the basalts that they returned, and that is something. That was something that we had to be very careful about because of the Wolf Amendment in US law, and I didn't want to go to jail. But we were allowed all the data that they got, and we were allowed to comment on the papers, and we were co-authors with them on the papers. So it's encouraging that that's going on. But politics. So this is when Chang'e 3 samples came back. I said I'd really like to get some in my lab. So I suggested to NASA that they look at a sample exchange with China, because 2 times they did it with the Soviet Union for the lunar samples. It actually created communication, and it created trust, and it was very productive scientifically, and I think diplomatically. NASA didn't say no, but it is with the State Department. And I was contacted just a couple of months ago by somebody from the State Department who was, what do you think about an international moon of the year? A year of the moon, sorry, moon of the year. There's only one moon. And I said, well, it should be a decade, but we won't go there. But I said, if you want to do that, you should consider a sample exchange with China. I said, I think it will make a lot of sense to do that. And I told him it was stuck in the State Department, so maybe he could follow up on it. And I'm not saying anything's going to happen, but we will see. I think that is an important step to open the door to collaboration at a higher level than just scientists with China.
Excellent. Thank you, Clive. All right, and next I see one from Madison Feehan of Space Copy. She says, hello. Clive, do you have any particular insight on how a foreign-owned small business that's based in the US can create partnerships with space organizations like NASA? How can we help NASA achieve its goals in studying and manufacturing ISRU technology?
Whew. All right. Well, getting a subsidiary in the United States is the way to go. iSpace has done that. They now have the American office, and are working with CLIPS, I believe, now. Although their first lander was not encouraging, but hopefully there'll be more. So I think that's the way to do it, is to have a US subsidiary that will allow NASA to work with them. I think that's something to be considered. But it's also looking at the technology that's going to be needed, and being part of the discussions that LSIC is having, getting involved with that and seeing what NASA needs and what you have to offer.
Awesome, thanks. And I just lost my question window. Oh, there it is. Okay, so now Donald Barker, who does have a question. So, how long do you think it would take at the current rate to get a station on the moon with a population similar to the summer population of McMurdo, Alaska, of 1,000 people?
Oh, not in my lifetime. Let's do it that way. But yeah, I'm not doing it for my lifetime. That's the thing. I got grandkids and great grandkids. They're going to see stuff like this, and I think that this is a generational. I work with the Humans to Mars, and they want humans to Mars in the 2030s. And first time I met with them, I said, I think you're being a little selfish. You want to see it, and you're probably not. So why don't we set the foundation so that our grandkids can see it, our great grandkids can see it? I said, that's what we need. We need, if we stampede to do it quickly, it'll be flags and footprints, or maybe not even that. But we need to do it to build up infrastructure. We need to build up capability, and I'll use the S word, sustainably, so that it's not just a one and done. It's not, Artemis 3 is not just a one and done. They're planning beyond that, so that we can. I asked the question today: when are we going to see the base camp in the architecture, the Artemis architecture? And well, we don't want to put it in the wrong place. Okay, so what do you need to put it in the right place? And that's what are the criteria? What are the requirements? So these are things I think that the lunar community can help with in terms of not putting the base camp in the wrong place.
Awesome. Brian Harvey now asks, Harrison Schmidt wrote on helium-3 from the moon, which seemed to fall on deaf ears. Maybe he was premature in that line of thinking?
Well, maybe he was, but maybe he wasn't. If you look at the advances in fusion technology over the last 20 years, it is remarkable. It is remarkable. And if you look in the theory, helium-3, which is more abundant on the moon than it is here because it's implanted by solar wind, that's the nirvana of nuclear fusion. No toxic byproducts, with a huge positive gain in energy. So I think it's important to think of the future. I don't think it's premature, but he made people think about it. And there are companies now set up to explore helium-3 mining. There are companies set up exploring sustainable fusion. So this is something to consider for the future, because if we can make it get a sustainable fusion reaction, and we can build fusion reactors, that's clean energy, and it's a lot of clean energy. And what do we hear all the time these days? We need clean energy. So I don't think it's premature. I actually think it's I think we need to be thinking about it now.
Well said. Well said. Dallas Bianoff asks, on the China question, this is more of a comment going back to something else, a note that for the China question, business to business seems to work well, as proven by nanoracks. The Wolf Amendment really suppresses government program interactions.
Yes, yeah, it does. And this is why NASA is part of the ISEG-G, because it's not a bilateral interaction with China. Would the Wolf Amendment prevent a US-China sample exchange? I hope not. I hope not, because I think that is, yeah. But I think that we need to keep pushing on that.
Okay, and Margarita Marinova asks, is there a very interesting question. Is there a proposed minimum set of measurements, such as specific instruments or data that they would provide, that would provide holistic resource/reserve characterization, given the resource list you had, Clive? Perhaps a package that could be developed and then become a relatively standard part of a mission?
Let's see. Hopefully you can see that. The answer is yes. And here it is. So this is what came out of LSSW 17. You can see this is just says for lunar volatile resource evaluation, but you can take that list in the column to the left there, and you can take it to other lunar resources as well. And I think that's something that is, we're going to need those data in order to show that lunar resources, not just polar volatiles, but also others are extractable and actually have reserve potential. So that's what came out of LSSW 17.
Awesome. another from Madison Feehan. One more question. What available publicly researched knowledge is available for the properties of constructing with regolith?
There's been work done with regolith simulant. Now, simulant is not a very good. I don't think it's very good if you're trying to use actual lunar regolith. And the big thing comes down to the nanophase ion that is developed through space weathering. It can change the properties quite nicely. But if you look at the 3D printing technology, and again, look at Icon Technologies, they have contracts to build 3D printed houses out of terrestrial regolith to fulfill housing requirements. So this is something that is working down here on using terrestrial regolith. On the moon, well, maybe we need a tech demo. I think that's something that would be really good to see.
Couldn't agree more. So I see that we're about at the top of our time here. So I'll wrap this up with a friendly reminder to take the survey I linked in the chat. That will really help our technical committee get some good data. And most of all, I would like to thank you, Clive, for taking the time to chat with us and answer all these great and well thought out questions. I'll be posting these slides and the recording of the presentation on various platforms. The video will be uploaded to YouTube. We're still working on getting that going for the last webinar as well, so stay tuned for that. And next month, we will be having Mr. Rob Mueller from NASA's Kennedy Space Center Swamp Works discuss lunar base construction requirements and planning. So with that, I'll let everyone go an entire minute early. And thank you again, Clive. It's been a pleasure.
All right, thanks very much. And thanks everyone for listening. If you have any questions, just shoot me an email. I will get to it eventually. So, all right. Thank you.
All right. Bye all.